I haven't written down the example yet for this, but for the average rate of change formula, it's just the change in f divided by the change in x. That's like the picture that would go along with that if we had some function like this. If this was, let's say, x, well, we'll just say x1, and then this is x2. I'll put it up here. So I have those 2 points. The average rate of change represents the slope, because it is the slope formula. So it's the slope of this secant line. Another way that we can write this is, well, first we can change x2, we'll change that to x1 plus h. So this distance here is h. You know what? Actually, I'm just going to change it to x. Never mind, just kidding. I'm going to leave it. Just changed my mind. So this distance here is h, because you're having x1 and then you're adding a little bit. All right. So if we want to find the average rate of change, then we could change x2 into x1 plus h. Yes, that's all fine and dandy. And then x2 into x1 plus h. If we want to find the slope at a single point, so slope of a curve at a point, then we can use this idea. So this will be the slope of a curve at a single point, which is the tangent line. So the slope of the curve at a single point, that's going to be, well, let's write down the slope formula like this with using x1 plus h. So I would have f of, that's my x2, so x1 plus h minus f of x1, all divided by, well, this thing, x1 plus h minus x1. And so those cancel out, so this simplifies to f, well, I'm not going to simplify, well, yeah, I will. I'm leaving some space here on purpose. F of x1 plus h minus f of x1 minus f of x1, yeah, divided by h. This is not yet the slope at a slope of a curve at a single point. This is not it yet. This is not the formula yet. Formula. Didn't know the formula yet. So what do we have to do? Because right now we're taking the slope from that point to that point. We can use our limit properties to make this go to 0. So we could say limit as h approaches 0, because then this point would slide up, closer and closer to this. We're not actually getting here, because then we would be dividing by 0, but we're approaching the same point. So it's almost like we're anchoring around x1 and we're just sliding this up and then seeing what the slope is for the secant line, the secant line, the secant line, and then if we take the limit as h goes to 0, we get the tangent line. So this would be the limit as h goes to 0 as well. And this stuff in red right here, that's called the difference quotient. This is actually the limit definition of the derivative. If you take the limit of the difference quotient, you get the derivative. And the derivative always tells you what? And then everybody would say, the slope of the tangent line. Or you could say, instantaneous rate of change. Either one of those. So let's look at an actual example. And you know what? I'm going to stop this video and then make the example in a different video. So this is actually slope of a curve at a single point. Let's say that. I mean, it is this one too, but I just simplified.